Hello developers, let's see what we have here. Roman numerals are represented by 7 different symbols: I, V, X, L, C, D, and M, according to this table. For example, 2 is written as II in Roman numeral, just 2 ones added together. 12 is written on X11, that is XII, comes to 12, where X is 10 plus 1, 11, plus another I, which is 1, 12. So Roman numerals are usually written largest to smallest, from left to right. However, the numeral for 4 is not III. Instead, the number 4 is written as IV because the 1 is before 5. We subtract it, making 4. The same principle applies to the number 9, which is written as IX. There are 7 instances where subtraction is used. I can be placed before V, X can be placed before L, C can be placed before D. Given Roman numeral, convert it into an integer. So here, we're going to create D to be our hash map that is going to hold this data. So I is going to be 1, V 5, X 10, just the same way as the table we're given here. Once we have our hash map ready, we need to have a sum. This is where we are going to add everything, then you're going to return it. So this is sum. Let's return it before we forget. Return sum. Now we come back here and ask ourselves, what do we need here? We need to look over our hash map when you get any value. So here it means we need to get the length of the string, which is going to be len s. Now because you're going to loop over, we need to find an index, a starting index, and you're going to name it I, then give it a value 0. So that means you're going to start at index 0. Now you're going to loop. I'm going to say while I, which is the index, is less than n, the length of the numeral that you've been given, we're going to check. You're going to say if the index is less than the length of the string minus 1, because we can't go outside the bound. And now we are checking, because there is an example like this one where we have to subtract one number from another one, which is this example C and M, because we have to start from left to right, and the left has to be greater than the right, otherwise we have to subtract. So here we are going to subtract. The letter at SI is going to be less than the letter at SI plus 1. So that is the next value. Then our sum is going to be the value of the next value, the next index, minus the value of the current index. And remember, when we do that, it means we've skipped from this point. We've calculated the difference between C and M, or X and M. So that means if you're going to move to the next index, you're going to skip this index because we've already used it here. So we upgrade the value of I by 2 so that we can move to the next index. Now that is a scenario where the right value is greater than the left value, which is the current value. There is another scenario where the left value is going to be greater than the right value, which is the normal way that you're going to expect. So here sum is going to be sum plus the value at SI. Then for this one, we don't need to skip several times, and here we need to add this symbol so that it can increase the index of I. Here we are going to increase the index of I by 1 because the value that is being used is only the current value. Now, once we are done with the loop, we're going to jump right outside the loop and you're going to return sum. So let's see. Yeah, so this one has already passed the test cases. Let us see the time complexity and space complexity of this. The time complexity is big O of you're only doing the looping once and you only have one input, which is the S. So now the S, it has this length. So you're going to have, it's going to loop this number of times because this is the length of S. So big O of N. And space is going to be big O. We're not creating any space. This is just a sum, which is a constant time. So which means the space is going to be 1, which is constant. So that is how we solve that question. And thank you so much for watching. I hope to see you in the next one. Bye bye.